Alright guys, so we're going to go ahead and start with some more derivatives just to keep brains nice and fresh. This will allow us to keep us sharp for when we do our Chapter 5 test. So again, I want to go ahead and talk about the difference between the first one and the second one. The first one has everything with the natural log. So because it has everything with the natural log, I can go ahead and do my natural log properties. However, the one to the left only has the top of the natural log. So, keep that in mind. Let's go ahead and start this first one. So I can go ahead and split up the part that's going on to every single term, which is the division. So I have the natural log of 4x squared root of 2x minus the natural log of 3x squared. Then I can go ahead and split up that multiplication that's going on there in that first term with addition. Excuse me. So I have the natural log of 4x plus the natural log of 2x. That was not what I wanted to do. To the 1/2 power minus the natural log of 3x squared. Now, something I want to talk about here notice how this second term has everything to a power and this third one does not. The only thing here to the power is the 3x squared. So because of that, we don't get to use the properties in this third term. We only get to use the properties in the second. Sorry about that. So, continuing on. I have the natural log of 4x plus 1/2 times the natural log of 2x minus the natural log of 3x squared. So I need to have my u's and other letters, if you so choose, for all of these. My u for the first one is going to be 4x. My derivative of that guy is 4. My v, in case, if again, some people like to switch letters, it helps them see it better, is the 2x. The dv is 2. The w in this last one is 3x squared. In the dw is 6x. So let's go ahead and apply the derivative now. So that first term will turn into 4 over 4x plus 1/2 times 2 over 2x minus 6x, over 3x squared. Four over 4 will reduce down to 1 over x. My 2's cancel here, but I'm still left with 1 over 2x minus 6 divided by 3 will be 2 on top. X over x squared gives me 1x on bottom. And then I can go ahead and combine, not what I wanted, my 1 over x, minus 2 over x, which gives me negative 1 over x plus 1 over 2x. And I feel like my face is on that one. So, again, I can go ahead and combine them because they have the same denominator. So 1 minus 2 is a negative 1, plus the 1 over 2x. Taking a look at the second term, we're going to have to use our quotient rule. We could do product if we wanted to. If you wanted to do product off to the side, I would pull out the 1/6 first and then do product of x to the negative second ln of 5x. The reason being is the 6 still needs to stay in the denominator, but if you just write 6x to the negative 2 technically only that guy would sync, when in actuality everything needs to sync. So again, if you wanted to do that off to the side, you're welcome to. I was just going to go ahead and do quotient rule because it's a little bit easier there. So quotient rule tells me that I have the bottom, so 6x squared, times the derivative of the top. Well, I need my u and my du, so let's go ahead and let my u be 5x, and the derivative of him be 5. So I have 5 over 5x minus the top, which is a natural log of 5x, times the derivative of the bottom, which is 12x, all over the bottom squared. Now I have to physically square everything, and I noticed in some of our homeworks we didn't do it, so I have to square the 6 too. So it's actually 36x to the 4th. I'm going to go ahead and do some simplifying and multiplying here. So in my division problem there, the 5's cancel. So then I can have a 1 on top, and I can take 6 times 1, which will give me 6x squared over x. I can't really combine anything in the last term, so I'm going to go ahead and put the 12x on front. And then I have one more step here in a second. I can go ahead and cancel out those x's, so I'm left with 6x minus 12x, natural log of 5x, over 36x to the 4th. And if you notice something else, we talked about this the day we did the product and quotient rule in class. I can actually divide out a 6x from every term, and when I do that, I'm left with 1 minus 2 natural log of 5x. If I do that on the bottom, I'm left with 6x cubed. So my simplified 100% final answer is 1 minus 2 natural log of 5x over 6x cubed. Also, I will take the original pink answer here. But if you wanted to do product rule and you wanted to double check yourself, you should get this final answer. And if you did product rule and you didn't, let me know and we can check it later. I'm going to go ahead onto today's notes. So here is our definition of an inverse function. We have seen inverses before. So before we go ahead and get into that, let's talk about inverse. Inverses undo each other. So for example, if I say addition, what is the inverse of addition? Well, subtraction, because addition and subtraction undo each other. Multiplication and division. Now what we're going to do is we're going to put this in terms of functions. So this is what's building off of yesterday's idea of function composition. So they're inverses if the composition will give me x for each time. So if I take g and plug it into f and I get x, and vice versa, if I take f and plug it into g, I should get each one. Something I really want to point out here is that if it is the inverse, it's f to the negative first of x. It's not saying that you're taking f and reducing it by taking it and making your fraction. That's supposed to be an f. That was beautiful. 1 over f. It's not saying it's f to the negative first where it drops down. It's saying that it's the actual function inverse. So what we're going to do is we're going to first start today by basically just switching our variables and solving for the inverse. So in order to find inverses, I start by taking my x and my y and switching places with them. So I have x is equal to 4y plus 5. Now I'm going to go ahead and solve for y. So basic solving tells me I'm going to go ahead and subtract 5. So I have x minus 5 is equal to 4y. Again, still trying to get y by itself. I divide everything by 4. My inverse of f is x minus 5 over 4. Next problem. Again, we're going to go ahead and start by just switching our variables. So I have x is equal to the square root of 16 minus y squared. And I got to get y by itself. My first problem was a little bit easier because I was like, oh hey, all you have to do is undo addition and subtraction. Well, I need to get rid of that square root. So to undo a square root, I'm going to go ahead and square both sides. So now I have x squared is equal to 16 minus y squared. Again, still trying to get y all by itself. 16 is technically being added here, so I'm going to go ahead and subtract it. So I have x squared minus 16 is equal to negative y squared. Again, trying to get y by itself, so I need to get rid of that negative sign first. So I'm going to divide everything by -1, and when I do that, all of my signs just switch. One extra step. Now we need to get y by itself. So to undo that square, we're going to square root. So the inverse here of f is the square root of negative x squared plus 16. All right, so verifying a function. To verify a function, we need to, according to my definition, they need to both be plugged in to prove that you can get x out. So I'm going to go ahead and do f of g of x, and then I'm going to also do g of f of x, because I have to show that they are inverses both ways. Because just because it may work for one does not necessarily mean it works for the other. So let's go ahead and start with taking, let's say f of g of x. So just kind of keep in with what we did yesterday. I have f of the cube root of x plus 1 divided by 2. Which means I'm going to have 2 times the cube root of x plus 1 divided by 2 minus 1. Pause. There's a cube here. I need a cube here. Okay, let's go ahead and keep going. When I solve these guys, order of operations tells me exponents first. So I cube that guy, but the cube and the cube root cancel each other out. So I'm left with 2 times x plus 1 divided by 2 minus 1. Next I look, well, can I simplify anything in here? Nope, so I go ahead and go with my multiplication step, and hey look, I divide and multiply by the same number. So then I'm left with x plus 1 minus 1. And x plus 1 minus x plus 1, x plus 1 minus 1 is just simply equal to x. So I can see that it does work the first way. Woohoo! But what about going backwards? So what about my g of f of x? Alright, well, I'm going to take g of f, which was 2x cubed minus 1. And I'm going to put that 2x cubed minus 1 into the cube root. Let me write this right here. Of x, which is 2x cubed minus 1 plus 1 divided by 2. And I know that x and the cube kind of go and form together. So I can go ahead and simplify my addition on top, because I can't do the division yet until everything on top is simplified. Negative 1 plus 1 is 0. So that cancels out for me. So now I have the cube root of 2x cubed over 2. And I know that my 2's can cancel. So now I have the cube root of x cubed, which simply is with x. So yes, these two functions are inverses. I got x both times. Yay! Keeping that in mind, I want you to try this one and see if you come up with the same answer that I do. So go ahead, pause the video, try this one on your own. Yes, you need to do both f of x and g, f of g of x and g of f of x. So you need to do both like we just did. I'm probably going to do them in a single color so you can see them. Alright, we should have gotten X both times. So, in this one we're talking about reflexive property of an inverse. When I have reflexive property, that means that my point of AB will be in the graph of my inverse if and only if the point BA exists. So it has to switch each coordinate. So that would look like I have some random graph, and say I have my f of x here, and it hits at the point, oh, let's say -3, 0. Wow, I can't name points today, can I? Same point there, but it's 0, -3. And that's my f of x. Then in a different color, pink's too close, my g of x, or my f to the negative first, or the inverse, has to hit at 0 and -3, 0. And they will reflect roughly across the line y is equal to x. They're supposed to. Granted, really bad sketch. Kind of reflect each other. Alright, so what does it mean to be one-to-one? For each input, there is a unique output. So, for example, when I plug in a number, I shouldn't be able to get the same number later on. Okay, next we have the horizontal line test. I know you guys, I went ahead and wrote this here at the top, so I wanted to talk about it. A function has an inverse if it passes the horizontal line test, meaning that it hits the graph only once. Horizontal means left to right. So looking at this guy, let's use neon green. I'm actually going to do this with the lines because I can't draw straight lines very well. If you notice, this first guy, no matter where I draw my lines, even if I go not in between, not on an actual function or an actual point, I only seem to be hitting the graph once at each individual point. So here, 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 and here. So this guy has an inverse. However, if I were to do the exact same thing with this guy over here, and it has to only hit once, so even though I could draw my line strategically down here, it has to work for every single point. And because, if you notice, I hit here, oops, that's not what I want. Because I hit here, hey, give me my points. There we go. Because I hit here and here, and here, it fails. So has no inverse. And you also need to make sure that you're checking your domain. So if it's, example, if it's only between, if it's bigger than 0, you need to make sure you're only looking bigger than 0. If you're smaller than 0, you need to be looking smaller than 0. If you're bigger than 2, make sure you're only looking bigger than 2. If you have questions on your calculator, let me know. I can help you with those. All right, there's your homework. You're going to go ahead and graph. You're going to find the inverses. Then you are going to graph both of them and give me a little mini sketch. What am I asking for when I say sketch? Something about this here, when we talked about what it should roughly look like. Does it need to be pretty? No. Do you have to have specific points? No. You just have to give me a rough idea of what I'm looking at. If you would like to do your regular function and inverse in 2 different colors, much preferred. Please label which is which so I know what I'm looking at. And the answer keys online. Thanks.